Yo, it's Tutor Amiro here. Today I'll be going through heat with you, well specifically heat change in a reaction, exothermic and endothermic reactions. Let's get straight into it. So when the heat is released into the surroundings, we know this as exothermic reaction, and when the heat is absorbed, it's endothermic reaction. Exothermic reactions increase the surrounding temperature, while endothermic reactions will decrease the surrounding temperature. So here is a frequently asked question. Students often ask me, why do exothermic reactions increase the temperature since it is the reaction that releases heat energy? Shouldn't the temperature decrease because the heat is released? Well, if you think like that, your logic is wrong because we're talking in terms of heat released to surroundings here. Let's visualize this. Now, if I have a hot beaker containing exothermic reaction inside and heat is released, right? That's the reason it's hot. When the surrounding temperature increases, that is when heat is released to the surroundings, so the surrounding temperature will increase. Now, moving on to the energy profile diagrams. How do you identify which one is which, exo or endo? Well, clearly this one is an exothermic reaction, right? But what we look out for are two things. Is the profile and the negative or positive value of the kilojoules per mole. And energy is released in this reaction, that's why the profile drops. Now, moving on to the next one. If the diagram looks like this, well, it's an endothermic reaction because, like I said, you look out for two things. One is the profile, another one is the positive or negative value of the kilojoule per mole. And energy is absorbed in this reaction, that's why the profile will increase. So to recap, we covered exothermic and endothermic reactions and what happens to the surrounding temperature, and increase and decrease in the surrounding temperature, and also we covered the energy curve. That's all for today. Thanks for watching, and as usual, I hope you keep studying hard.